We have done this before, except, children, it's doing multiplication, division, or the operations like we did before, except now we're doing small numbers, which means you have to keep in mind the negative exponents and what happens with negative exponents. For example, let's say I have this. This will be a good review. 4 times 10 to the 8th power times 2 times 10 to the negative 5th power. Which, let's not forget what that means in the real world. You know, we do all this stuff and then we forget really what we're doing here. This is 4 with 8 zeros after it. Is that 8? It's like 8. 400 million. This, since it's a negative exponent, is a 2 behind 4 zeros. Why is this a 5 and I only put 4 zeros there? Can anybody tell me, Landon?
Because you're supposed to be the first zero before.
Right, because the first move is getting in front of the 2. So that takes up one of the 5, and then you add the 4 zeros there. Okay, we are multiplying those together. I hope that's what you were saying. Okay, and I particularly don't care for that because there's a lot of zeros, a lot of decimal places that's going to just get it messed up. You don't have to do that. What you do, what is the rule when you multiply scientific notations? You, Ryan?
You add the exponents together.
Well, multiply the left side first. You get 8, right? And then you add exponents. But here you have to be careful because one of your exponents is negative. What happens when I add an 8 and a negative 5? Alex?
You get a negative 45.
I am
Or
adding them,
or
so.
down.
Huh?
3.
I get a 3, positive 3. Which if I multiply this together, I get 8,000. My answer is. Okay. If those things both happen to be negative, if that was a negative 8 and a negative 5, what would my answer be? 10 to what power, David?
Negative 3.
Negative, no. Negative 8 and negative 5 put together, Maggie, is? It is not. That's if you multiply. Adding 2 negatives together puts you farther in the negative. Brooke, it's negative 13. You have to be careful with that because that's exactly what it would be. And now, oops, I didn't really want to do that. That's okay. And then with division, you have to be particularly even more. Write down this problem, careful. 8.1 times 10 to the negative 4 power over 3 times 10 to the negative 7 power. Again, thinking about what this really means in real life, what you're doing, you are taking 0.00081 and dividing it by 0.1, 2, 3, 4, 5, 6, 7, 0.00003. Again, a lot of decimals to keep track of, and you don't. This makes it much easier. The rules for division are the same as really multiplication. You divide 3 into 81, which ends up being what? 2.7. Okay, times 10. Now, what's the rule with exponents when you divide? You subtract, but here's where you have to be careful. Don't go too fast on this. I have a negative 4, and I am subtracting a negative 7 from it. Which means, in essence, what? 2 negatives, when they're together like this, actually change it to a positive. It's actually a negative 4 plus 7. So the answer is going to be negative 4 plus 7 is a positive 3. Sorry, positive 3. It's 2.7 times 10 to the 3rd power. Please, please, please take your time. If you're subtracting a negative, that's actually adding. Let me give you one because I can tell you are specifically, particularly mesmerized by the whole shebang here. Don't they give us something hard to do? Sure, how about this one? 4.8 times 10 to the negative 3rd 4.8 times 10 to the negative third divided by 1.3 times 10 to the second power. 3 times 10 to the second power. Give me an answer, please. Maybe we'll do one more. Should have an answer, I hope, for this one here. For the top one there, David, it ends up being
1.6 times 10 to the negative first power.
agree or disagree? You got a long way to go here. 4.8 divided by 3 is 1.6. I do have it times 10. But this is a positive 2, so when I come up, I just subtract 2. Negative 3 minus 2 is negative 5. You're not subtracting a negative here, you're subtracting a positive. It's normal subtraction. Negative 3 minus 2. This should be a negative 5. How many people got that? But we're afraid to go contrary. Okay, if this would have been a negative 2, yes, because then you're subtracting a negative, becomes positive, and it becomes a negative 3, but not so much here. How about this one here? So we get an answer for this one. 7.5 times 10 to the negative third times 2 times 10 to the negative fourth. You end up with going once, going twice. Andrew Stupert thinks he knows.
15 times 10 to the first.
Oh. I wish well, 2 times 7.5 is 15, which in itself is not good because we can't have 15. However, when you add negative 3 and a negative 4 together, what do you get?
Negative 7.
Correct. But that's still not right, simply because it's not scientific notation anymore. You need to move what and do what, Alex?
You need to make the decimal place between 1 and 5.
So it moves back one place, and here's another place we have to think a little bit. I get 1.5. If I make this one smaller, I have to make this one bigger. Negative 7 plus 1 is negative 6. So in the world of integers can be a confusing lot. The more you work with them, the better off you get. How many people had that? But that's what I thought. Maybe I should give you one more. How about this one? I'll just make it up in my head. Why not? How about 5.4 times 10 to the negative 6th power times 5 times 10 to the 8th power. See what you get for that. My initial thoughts are that 5 times 5.4 is going to give you 27. I multiply the 10 to the negative 6 times 10 to the 8th, that's going to give me a 10 to the what? 8 minus 6 is 2. Again, I can't keep that, so it has to be moved from here to here. You made it one smaller, so you need to make that one bigger. It should be 2.7 times 10 to the third. How many people there? Did we make some headway? 2.7 times 10 to the third is what real number in standard non-scientific form? David?
2,700.
2,000. You tell we are